In this video, I am going to solve these three equations using Gaussian elimination method with row interchanges. First of all, you need to write the equation in the augmented form. 0, 3, 4, x1 is 0 here because x1 is not given, 2 and like this, okay? And now in the pivotal condensation method, it is actually same like Gaussian elimination method, but there is one step more. What you need to do is, you need to look in this column in the first step. Okay, just look into this first column for the numerically largest value. Numerically largest value is the 4. Then you bring this to the first row. Numerically largest means basically you need to ignore the minus symbol. If this is minus 4, 3 and 0, then 4 is, this row is numerically largest. If this is minus 5, for example, then the 5, that's all. Minus you just ignore. Okay, no minus. Minus 5 means just ignore the minus. 5 is the numerically largest value. Okay, I hope you got it. So then once you have done that, then the next procedure is exactly same like in Gauss elimination method. You need to look at this diagonal and you need to make these three terms 0 in the Gaussian elimination method. Okay, in the next step I have done the further operations. Okay, so now you want to make this term 0. Write this 3 here, add minus to that, divide this by the first row element 4, multiply this by the row 1, and since this is going to R3, R3 will be R3 plus this. Okay, then you will get this as a 0 here. Okay, if you simplify this, R3 will be R3 minus 0.75 times the R1. Okay, this is R1. R3 minus 0.75 times the R1. If you do it, this is 3 minus 0.75 times the 4, 4 minus 0.75 times the minus 2, 5 minus 0.75 times the 1, 11 minus 0.75 times the 18, right? And if you simplify this, you will get the next matrix. This is the matrix you get. And now once you got this, you need to again, you have to come here, you have to first ignore the first row, look at the second row here, second row and the third row. In the second column, you need to now look at numerically largest value here, 5.5. 5.5 is the numerically largest value, and you bring this to the this position. So R2 and R3 you are interchanging. This will come here, 5.5, 4.25 minus 5 minus 2.5, this one 342 will come here. And now afterwards the next step is you need to make this 3 as a 0. All the elements below this diagonal has to become 0 in the Gaussian elimination method. Okay, so now in the next step what we are going to do, I am explaining this here. Now since you want to make this 0, write 3 here, add minus to that, divide this by this row now, 5.5 times the R2, this, and the R3 plus this term should point to the R3. Then R3 will be R3 minus 0.545 times the R2 if you simplify this. Okay, so this is the row operation which you are going to do on the R3. If you do it, then it will be 3 minus 0.54 times this one, 4 minus this is, okay, sorry, that is something has happened there. This is actually 4.25, and now I have written this step here, and now this using this operation, okay, using this row operation. Now you come to the next step. Once you have done this operation, you will get this matrix. 1.68 times the x3 will be equal to 3.36. Okay, this is a multiplication, matrix multiplication, and if you solve for x3 you will get this. And now by back substitution you will solve for second equation, will be 5.5 times x2 plus 4.25 times x3 will be minus 2.5. Then you will calculate for x2, and here you will substitute for x3. By back substitution method you will calculate for x2. In the same way you will say 4x1 minus 2x2 plus 1x3 should be will be equal to 18. Then you will calculate for x1 by substituting x2 and x3 values in this equation. Then you will get x1 equal to 3. Okay, to summarize, what I have done is I have written the augmented form of the given equations, and then I have looked for the numerically largest values in the first column, numerically largest value. Then I have replaced the first row with this row, okay, with that row, and then I have done the row operations. Then again, after the first step, I have looked for the numerically largest value in this. Then I have interchanged that. Then I have done again the row operation. Then afterwards I got this matrix. Then I have solved for x1, x2 and x3. That's all. That's all, friends, for this video. If you have any doubt, please put a comment below. I will try to answer that. See you in next video. Bye bye.